the constant term. The constant term is the difference between consecutive terms. This relationship defines an arithmetic sequence. An arithmetic sequence, also called an arithmetic progression, is a sequence in which the difference between consecutive terms is a constant. This constant is called the common difference. For example, sequence AN is an arithmetic sequence with common difference D if and only if AN plus 1 minus AN equals D for all numbers n. From this definition, we can see that if this is an arithmetic progression, then A2 minus A1 is equal to A3 minus A2. This in turn is equal to A4 minus A3 and so on in the sequence, all the way to AN plus 1 minus AN equals D. Therefore, we can say that A2 equals A1 plus D. A3 is equal to A1 plus 2D. A4 is equal to A1 plus 3D, and so on. In doing this, we have proved a theorem for the general term AN. If sequence AN is an arithmetic progression with the first term A1 and a common difference D, then the nth term is given by the equation AN is equal to A1 plus, in bracket, n minus 1 times D. It is time for our first activity, students. Given an arithmetic sequence with the first term of 2 and the common difference of 8, find the first 5 terms and the 25th term. Do your best. I will see you in a few minutes.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I am confident that you had no trouble with our first activity. The first term of the arithmetic sequence is 2. Therefore, A1 equals 2. A2 equals A1 plus D. This is 2 plus 8, which equals 10. A3 equals A1 plus 2D. This is 2 plus 16, which equals 18. A4 equals A1 plus 3D. This is 2 plus 24, which equals 26. A5 equals A1 plus 4D. This is 2 plus 32, which equals 34. To find the 25th term, let us use the formula that we learned. A25 equals A1 plus 24D. This is 2 plus 192, which equals 194. Did you find all the correct answers on your own? If you did, great job. Now, let us see how an arithmetic sequence can relate to practical problems. Baruch just got a new job. His starting wage is 15,000 birr a year. At the end of every year, he gets a pay raise of 1,800 birr per year. Students, I would like you to use the formula we have learned to find out what Baruch will be earning at the end of his 10th year. Then, plot the sequence graphically. You can get started right away.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, students. Biruk's initial wage is 15,000 bir. His annual pay raise is 1,800 bir. Thus, his wage after the first year is 16,800 bir. His wage at the end of the second year is 16,800 bir plus 1,800, which is 18,600 bir. In this way, the rising values of Biruk's wage form an arithmetic sequence. We can use the formula AN equals A1 plus N minus 1 times D to discover Biruk's wage after 10 years. A1 equals 16,800 and D equals 1,800. AN equals 16,800 plus 1,800 times N minus 1. N minus 1 is 10 minus 1, which equals 9. 16,800 plus 16,200 equals 33,000. Therefore, Biruk will be earning 33,000 bir at the end of his 10th year with the company. When we plot this data graphically, we get this result. Notice that the graph follows the path of a linear function. We can deduce from this that arithmetic sequences behave like linear functions. Their graphs are point graphs that form straight lines when joined. Do your graphs look like mine? If so, you have done a great job. Let us look at an example of arithmetic progression together. Let AN be an arithmetic progression with A1 plus A3 equals 14 and A2 plus A4 equals 25. We will use this information to find A1, D, and AN. Since AN equals A1 plus N minus 1 times D, then A1 plus A1 plus 2D equals 14. Therefore, A1 plus D equals 7. 2 times A1 plus D plus A1 plus 3D equals 25, which we can express as 3 times A1 plus 5D equals 25. We have established that A1 equals 7 minus D. So, let us substitute this into our equation. 3 times 7 minus D plus 5D equals 25. We can simplify this to say that 21 minus 3D plus 5D equals 25. So, 2D equals 4 and D equals 2. A1 equals 7 minus 2, which is 5. Now we are ready to find AN. AN equals A1 plus N minus 1 times D. When we substitute the proper values, we find that AN equals 5 plus N minus 1 times 2. Therefore, AN equals 2N plus 3. I hope that you were able to follow this chain of reasoning, students. Knowledge of arithmetic progression will be very valuable to us as we continue this unit. That is all the time we have for today, students. We have learned about arithmetic sequences and how they can be applied to real-world problems. We have also seen how arithmetic sequences graph in the same fashion as linear equations. Until next lesson, thank you, teacher. Thank you, students.